Right, in this lecture we've already looked at this concept of e to the minus whatever you put in the x's you can then use as your force of interest and work out any present value at any point. And then we've looked at spot rates and forward rates, but the reality is that things actually work the other way around. The market doesn't give us spot rates or forward rates. What the market gives us is bond prices, and then we can work out what the spot rates and forward rates are. So to work out the yield curve, to work out what the spot rates and forward rates are, we have to flip the thing over. Okay? So supposing we have 3 bonds in the market, and they're all 100 nominal. So at term 1 year, the price is £97. At term 2 years, the price is £92. At term 3 years, the price is £84. Okay, so we can, looking at our definition of spot rates, we can easily work out what the spot rates are. Okay, so 100 times e to the minus s1 times 1 is equal to 97. Okay, similarly 100 times e to the minus the spot rate at term 2 times 2 years equals 92, and 100 times e to the minus the spot rate at 3 years times 3 equals 84. However, we want to turn this round so we get the rate of interest at each point in time. Okay, so we also know that 100 times e to the minus integral between 0 and 1 forward rate of interest t equals 97. Okay, but what do we do here? Well, what we do here is we really just extend this thing out. So 100 times e to the minus 0 to 2 f of t dt equals 92. Okay, and what we're going to have to assume, since we only know the bond prices at time 1, time 2 and time 3, we're going to assume that the forward rate of interest is constant between time 1 and time 2, between time 2 and time 3, and between time 0 and time 1. Okay, so we're going to assume this is a constant, and we get 100 e to the minus f 0,1 okay, equals 97. If we assume f is constant between 0 and 1 and constant between 0 and 2, this thing becomes 100 e to the minus f 0,1 minus f 1,2 equals 92, and this thing becomes 100 e to the minus f 0,1 minus f 1,2 minus f 2,3 equals 84. Okay, from which all I need to do now is solve this. So f 0,1 is equal to 97 over 100 log and minus it, so minus log 0.97. Okay, so I then put that in there, 100 e to the log 0.97 times e to the minus f1,2 equals 92. Which reduces to, for fairly obvious reasons, 97 e to the minus f1,2 equals 92. So f1,2 equals minus log 92 over 97. And hopefully you can do the algebra yourself here, but you're going to get f 2, 3 equals minus log 84 over 92. Okay, so we've now got the interest rate at every point on the yield curve. Okay. So it may just be worth putting those numbers in. So that is 3.05%. That is 5.29%. And that is 9.097%. Okay, and you can recheck that back quite easily by saying, well, what is 100 times E to the minus 0.0305 minus 0.0529 minus 0.09097. Okay, and you should find that is equal to 84. Okay, and similarly, if we want to know what the price of a bond is at time 1.5, what do? Well, we go 100 times E to the minus 0.0305 minus 0.0529 times 0.5. Okay, that will give us the price at t equals 1.5. Okay, so we've now got, we can reverse engineer from the bond prices, we can reverse engineer the entire yield curve, and once we reverse engineer the entire yield curve, we can then calculate the price of any bond at all. Okay, easy.